Hi, in this video we are going to discuss how we can implement stack using linked list. So till now we have seen how we can implement stack using arrays. So basically we have seen how to insert in a stack, how to delete some element from the stack, and how to check the top element of the stack and check the size of the stack and check if a stack is empty or not, right? So these are the basic operations that we're going to perform on the stack, right? So in case of arrays, we have done all these operations in O of one time. Similarly, our target in case of linked list as well is to perform all these operations in O of one time itself. Okay, so now let's see how we can do that. So what was happening in case of arrays? We were taking this array and say this is a stack and we need to push the first element. So the first element will be inserted here. Then the second element will be inserted here. Third will be inserted here, and similarly, so this is the fourth, right? So this is how we were implementing stack using linked list. Now in case of linked list, we have nodes, right? So we need to store these elements inside nodes itself. Say this is our linked list and we need to store the elements here. So say we have to insert one here, so we have inserted one here, then two, then three, and four, right? And say this is on 100, this is on 200, and this is on 300. So it's 100, it's 200, and it is 300, and it is pointing to null, right? Okay, so we know that in linked list the first node is our head node, right? So okay, so we'll be working over the head node itself. Like we have to save this head node in order to save the whole list, right? So we know that inside a class stack, we must have a pointer that is the node star head, right? Which will be the address of the first we can say node of the list, right? So it will be pointing to the first node of the list. Okay. So initially, if the list has no elements, like the list is empty, then we know that we can have a constructor of this class and take head is equal to null initially. That basically means that our list is empty, right? Okay. So now let's see how we can perform these operations like one by one. Let's discuss them. So I want to insert something. Our target should be to do in O of 1, right? Okay. So say I have this thing insert 1. Okay, so what will happen? First of all, we need to create a node with data 1 in it, right? And this will be null. Let's name this node as new node. So let's name it as n. Okay. Okay, so now we have say insert 2. Now we know in this case that as our head is equal to null till now, so if head is equal to null, then make this new node as our head node, right? So we have done that thing. Now say I want to insert 2. So what I can do, I can simply make a new node with data 2 in it, and this is null, and connect the last node with the next node. So the last node here is the head node itself because it has one element only. So we have to connect this last node with the new node. So it's done, and it will basically store the address of this node, right? Okay, so this time this will be a new node, right? Now say I want to insert 3 inside it. So how I can do that? Again, I need to create a new node 3, and this is again null, and this is the new node this time, and say this is on 200 address. So again I need to connect the last node with the new node, right? The last node of the list with the new node. Okay, so this will contain 200 and it is connected, right? Say now I need to insert 4. Now let's see how we can do that. I have to go to the head node first and then traverse this whole list, come to the last node, and then attach the fourth node here, right? So it will be something like this. This time this will be the new node. Say it's on 300, so it will contain 300, right? Okay, so how much time this node has taken to insert itself? It has started from the head and traversed the whole list. So basically it has traversed all the nodes. So say the number of nodes are n. So it would have taken order of n time, right, to insert it. But our target is to achieve O of 1, right? So let's see how we can do that. Okay, so this is the status of our list. 1, 2, 3, and 4, right? We have inserted these nodes and it is taking order of n time. But now I want to do this thing in order of 1 time, right? So I can do one thing. I can have my more pointer that is pointing to, let's name it tail, and initially it is also null, right? So say the list is empty, like it doesn't contain any nodes. So head and tail both will be at null, will be pointing at null, right? Now say the first node came. So say we have called the first operation here. We have to push one. So a new node will be created with one as the data, and this is null. So as head is null, so we the head and tail both will start pointing at the same node, right? Okay. Now say we need to push 2 inside it. So again, a new node will be created with data 2 in it, and this will be null. Now what we need to do? We need to simply do in tails next. We need to have the new node. Let's name it as n. Okay. What is tails next? This is tails next. Say this is on address 100. So in tails next we are doing n. So 100 will come here and this node will be connected with this node, right? And now what we need to do? Just remove the tail and make the tail point to this node. Okay, so basically tail is equal to tail next, right? Again, say we have the push function and we want to push 3, right? So say this is a new node and this is null, right? And this time this is the new node, right? And it say it's on address 100. So again we'll do the same task. On tails next we need to do n. So n is 200. So after doing this, this will be connected to this, and tail is equal to tail next. So tail will be this node, right? Okay. So now let's say I want to push 4. Okay, so what it will do, it will simply, first a node will be created with data 4, right? And this will be null. And what I need to do now, I simply need to, connect the tails next with this and make tail is equal to tail next. So if you have seen one thing here, this is the tail here. We are basically, not traversing over the whole list, but just, playing with tail only. We're changing the pointer of tail only. Like whichever will be the last node, tail will be pointing to that node itself, right? So I think now it will be taking off 1 time, right? Okay, so we have achieved our push function and it is taking off 1 time, right? Okay, now let's check it for top. So the next status is this time we have this is our head. The first node is head and this is tail, right? We know this thing, and this is off 1 this time. Okay, so now what we can do, simply I need to check the top element, right? This is the second operation, say we want to do. So which is the top element, which is the last element inserted? I think 4 is the last element, so we can simply return tails data, right? Okay, so we don't have to do anything, we just need to go to tail and return the data of tail, right? Okay, so this can also be done in O of 1. So we have top function in O of 1 again. Okay, now let's see the third function, that is to pop something. Okay, so what do we need to pop from the linked list? The last element inserted, that is 4. Okay, so I can simply remove tail. Okay, it is done. This has been removed. Now say I have called pop again. So this node should be removed, but we don't have the pointer tail here because we can't do tail is equal to tail previous in case of single linked list, right? We can't go to the previous node, right? So here we have to again, go through the, traverse the whole list and then delete the element. So this will again come into O of n, right? So we have to do something. We have to again, achieve a target, that is O of 1. So let's see how we can do that. Say this is our list 1, 2, 3, and 4, right? So here we have head, this is tail, and let's maintain another pointer. Let's name it P, and it will be previous to tail, right? Okay, so what we can do now, say I have called the pop function. What it will do, it will remove the tail, right? So before removing the tail, let's store the tail into some temp and delete temp. and make tail is equal to p. So now tail will be here, right? Okay, so tail has come to the previous node. Great. So now let's again call the pop function. Now what will be done? This tail will be removed again. So let's remove the tail. Okay, so second time also the pop function worked fine. Okay, say now we need to do pop again, right? This has been removed, this has been removed. We have, the previous pointer that is previous to tail, but we don't have any pointer here, right? There can be any number of nodes in the list, and we can remove any number of nodes in case of stack, right? So how we can do that? Can we remove this node somehow? No, we can't remove it. Again, we have to traverse the whole list and come to this node to delete it, right? So I think this thing also will not work. It will again take O of n time. This can effectively remove one node with the help of tail, and this can effectively remove two nodes with the help of tail and previous. But what will I want to delete three nodes or four nodes or any number of nodes. So again the complexity will be O of n, and we need to improve this, right? So our pop function is not working fine in this case. It is taking O of n, right? And we know that. So what can we do? Okay. Okay, so now let's change the insertion procedure, like the insertion operation. Okay, so say this is our list which is empty right now. Okay, and we have to push one inside it. Right, so a node will be created with data 1 and this null, and say let's name it as n, right? So what will happen? This time we don't need this tail pointer, right? We'll be working without it. Let's see how. Okay, so this is the first node, so head will be pointing here only, right? Okay, now say we have to push 2 here. So instead of connecting it to the end, let's connect this node in the beginning, right? So what will happen when we'll do this? A node will be created, and this will be a new node this time. Sorry, this will be a new node, right? Now what we need to do? We can do one thing in ends next, like we need to connect it like this. We don't need to connect it like this, right? This is the case that we need to do this time. Every time a new node comes, we need to push that node in the beginning of the list. So how we can do that? Just simply do in ends next, I want to push head, right? Say this is an address 100 and this is an address 200. Okay, so it is ends next this value, right, which is null right now. In ends next I'm pushing head, which is 100. So this will be done, and yeah, this link will be created, right? Now what I need to do, as we know the first node of our list is always head, so I need to make this node as head, and this is the n, right? This is n, right? So I simply need to do this thing, and it will effectively create my list as this. This is 2 and this is 1 and this is null, right? Okay, so now let's say I want again to be pushed 3 inside the list. So again create a list, sorry, node with 3 data, and this is null, right? Now what I need to do, you need to again connect it like this. Yeah, okay, that's great. So how we can do that? Say this is 300, right? This is on the address 300. So just simply, do ends next is equal to head. So what is ends next? Ends next is this value, right? Because this is n now. So we need to write head here. Head is this. This node is head this time. So it will be replaced by 200, right? And head is equal to n. So this was head and this is n. So now we are doing head is equal to n, basically means that this will be our head this time, right? So this is the status of our list. 3, 2 and 1, right? And this is null, right? And this is the head node. Okay, now let's perform pop operation and top if they work fine in it. Okay, so let me create the list again. 3, 2, 1, and see in the same way we have inserted one node 4 here. Okay, and this is head, say. Now what I need to do, I need to pop an element from it. So what I can do, let's create another pointer and let it start pointing to head. So what will happen if I'll implement the statement? Temp will start pointing here, right? And then I can do head is equal to heads next, right? Because 4 is the last element that has been pushed and we need to remove that element, right? So yeah, this is done. So head is equal to heads next. So head will come here. And we need to remove this element, right? So I can simply do delete temp. This will basically remove this element, right? Okay. So again, this task has been done in O of 1. Insertion was done in O of 1. Now let's see how we can do the top operation. So which is the top element here? 3. 3 is head. So I can simply return heads data, and I think this will work fine, right? And this is also done in O of 1. So now pop has been done in O of 1, top also and push also. Okay, now let's check for these two functions. So how we can do them? So say we have the size function. This will basically return the size, right? And say we have the pop function, is empty function, and it should check if my list is empty or not, right? So we can simply check it with the help of the size. If size is 0, basically means that a list is empty, a stack is empty, we can say. Else I need to return false. Okay, so let's understand how we can perform these operations. Okay, so now let's discuss how we can calculate the size and check if our stack is empty or not, right? So say this is our list. It contains these elements, and one is pushed at the end, right? Like the last element, and this is the head, right? Okay, so the size should be 4, right? And is empty is false in this case, right? So how we can do that? Let's say now our list is empty. Just forget about this. So our list is empty and we are pushing the first element, right? So first element will be inserted here, and just at the time of insertion we can initialize it with 0. Just do one thing, do size plus plus, right? Okay, so every time you will do size plus plus, basically the size will be incremented by 1, right? So you have pushed 1 here, so the size will become 1. Now if you have pushed 2, like this, so again we have to increment the size by 1, so the size will become 2, right? If we'll do push 3, so the size will become 3, right? And it will be something like this. The list will be created, right? Now say I want to pop something, basically means that one node will be removed, right? So if one node will be removed, basically means that a size will be decremented by 1. So every time we need to remove something, like some node, we need to do size minus minus, right? Again I have called pop, so again I have to do size minus minus, and these two elements have been deleted. Now what's the size? Size was 0, here it become 1 2 3, and now it become it decremented by 1, so it again become 2 and 1 here, right? So basically a size is 1, and is empty can be checked by this thing. If a size is 0, basically means that there are no nodes in the list, so basically means that a stack is empty, right? So we simply need to return true from here, else we need to return false, right? So this is how it works. This is the complete flow, and yeah, we have achieved our target to do all these things in O of 1, right? So now we need to write code for that. So let's write the code for it. Okay, let's see how we can code it. So this is basically, to create a node of linked list. So we know this thing, how to create a node. So this contains data and this is a pointer to the next node, right? Okay. So as discussed, we have to, take two things in our stack. That is, one is head, and the other thing is that we need to maintain a size for checking the size, right? And initially, both of these have been initialized with null. Now say we need to push something inside our stack. So we have called push function, push 1. So what will happen? A node will created this node star n. So a node has been created named n, and we have pushed 1 here, and this is null, right? Okay, so in ends next we are doing head. So till now we don't have any element in the list, so this will be head, right? With the statement head is equal to n, and we will do size plus plus. So size was 0 and we have done size is 1, right? Okay, say now we want to push 2. So now what will happen? We have to again create a node n. So we have created a node n with 2 data and this null. Now we need to do in n's next 2 head. So this is n this time, and in say this is on 100 and this is on 200. So in n's next, so in this thing we have to write head, like the address of head. So after doing this, there will be this connection, right? Okay, so now I want to push 3. So how I can do that? Again, yeah, and the size will be incremented here as well. So this time this will be n. Say this is an address 300 and 3 will be there, and this will be the address of this node, right? So 200, and this will be connected. And this time this will be our head node, right? So this is how we can, push an element in our stack using linked list. Now say I want to pop. So as we are using int here, like the function type is int, so we need to return the data of the node that we are deleting, right? So if you want void here, so you don't need to write this statement, and this one as well, right? Okay, so what we are doing here, say I want to pop now, and yeah, this node star temp is equal to head, so temp will start pointing to head. So this is a temp, sorry, this is our head, so temp will start pointing here, right? Okay, so then we need to do head is equal to heads next. So this is head and its next is this. So head will start pointing here and this will be removed. Yeah. Then we need to do delete temp. So you need to delete temp, like you need to delete this node and do size minus minus. So when we have inserted 3 here, the third node, so size was 3 and we have decremented it to 2, right? So our status now is this is 1, this is 2, sorry, this is 1, this is 2, right? Okay, and this is null. This is how our list look, and it has a size 2, right? Now say I want to check the top element, right? So for checking the top element, how we can check that? Okay, yeah. So for checking the top element, if our stack is already empty, we need to return 0, else you can return heads data. So which is the top element here? This is the top element, right? Because this is inserted at last, because this has been removed, so now we are left with this one. And yeah, this is our head node, so we simply returned heads data, right? Okay, so if you want to return size, then size is 2. So in get size function, size will be returned if you want to check it is empty or not. So you can simply check it by checking the size. If the size is 0, basically means that a stack is empty, else it has some elements, so it is not empty, right? Okay, so this is how we can implement stack using linked list. I hope it is clear to you. Thank you.